Picture this. You've just walked into a crime scene, but the culprit, literally invisible to the naked eye. So how on earth do you catch him? Well, in organic chemistry, you become a molecular detective, and your magnifying glass is the infrared spectrum. Today, we're going to learn exactly how to read those invisible clues. Welcome to this explainer. If you're looking to totally demystify IR spectroscopy and absolutely crush your Edexcel AS Chemistry exam, you are in the exact right place. We're going to equip you with the precise tools, the exact wave numbers, and the ultimate examiner secrets you need to succeed. Okay, let's quickly check our roadmap for today. We'll start with what infrared spectroscopy actually is. Hit the key bond absorptions you need to learn, go through a step-by-step spectrum reading, identify an unknown compound, tackle some Edexcel past paper practice, and wrap up with the final exam tips summary. All right, Section 1. What is infrared spectrometry? We're decoding the vibrations of invisible bonds. Let's get right into the basics of how this technique actually works. At its core, different bonds and molecules are constantly stretching and bending at very specific frequencies. It's kind of like they're dancing. When we fire infrared radiation at a molecule, its bonds absorb that energy at their own characteristic frequency, which makes them vibrate even more. Now look at the y-axis here. It measures transmittance. 100% at the top means the radiation passed right through. So think of those sharp dips dropping down as the unique fingerprints of our invisible suspects absorbing that energy. This essentially gives us a map with two distinct halves on our x-axis, which measures wave number. From 4,000 down to 1,500, that's your functional group region. This is your primary hunting ground for identifying specific bonds. But below 1,500, that's the complex fingerprint region. So the strategy is, find your suspect on the left, but absolutely confirm their exact identity using the unique fingerprint on the right by comparing it to a known reference spectrum. Moving on to Section 2, Key Bond Absorptions to Learn. This is your Edexcel data booklet cheat sheet, where we meet the usual suspects you absolutely need to memorize. This right here is your ultimate cheat sheet. Honestly, I'd pause the explainer right now and review these exact wave number ranges and appearances because they are pulled straight from the Edexcel data booklet. Notice the OH bond in alcohol sitting in a broad range between 3230 and 3550, and then look at that incredibly distinctive, sharp C equals O dip right around 1680 to 1750. You've got to lock these numbers in. Now, what's really fascinating here is how just looking at the broadness of that OH dip instantly tells you if you're dealing with an alcohol or a carboxylic acid. An alcohol OH, it's like a broad valley between 3230 and 3550. But an acid OH is very broad, stretching all the way from 2500 to 3300. That is wide enough to literally swamp and overlap the entire CH region. So if you see a massive dip hogging all that space, your brain should immediately scream acid. But here's a crucial point about writing this down in your exam. Examiners are notoriously strict about this. Never ever just name the atom. Writing oxygen will score you a big fat 0. You always have to name the bond, like OH bond stretching, and the functional group, like in an alcohol, to actually secure those marks. In chemistry exams, specificity is your best friend. Section 3, Step-by-Step Spectrum Reading. This is the detective's flowchart, where we build a reliable methodology for analyzing literally any spectrum they throw at you. By strictly following this logical flowchart every single time, you turn a chaotic, scary-looking graph into a super simple, unbeatable checklist. Step 1, only look between 4,000 and 1,500. Step 2, hunt for a broad OH. Step 3, hunt for a sharp C equals O between 1680 and 1750. Step 4, combine your clues. If you've got both, bingo, it's a carboxylic acid. If you only have the C equals O, it might be a ketone or an aldehyde. And finally, Step 5, use that fingerprint region for your absolute confirmation. All right, Section 4, Identifying an Unknown Compound. It's time to put your new toolkit to the test with a guided worked example. Okay, detective, I want you to actively test yourself right now. Look closely at these clues. We have a very broad absorption from 2,500 to 3,300. We also have a strong, sharp absorption at 1,710, plus some CH absorptions around 2,900. Try to deduce the functional group before we move on. What are we looking at? Let's walk through it together. That very broad range from 2,500 to 3,300 tells us we definitely have an OH bond, but it totally rules out a simple alcohol because it's just too wide. Then, that sharp stalactite at 1,710, That confirms a C equals O carbonyl group. So if you guessed a carboxylic acid because you spotted both the swamped OH region and the C equals O group, you hit the nail on the head. You are absolutely right. Section 5, Edexcel past paper practice. Let's enter exam conditions and elevate this by tackling some real past paper questions. Take a quick second to grab a piece of paper. I want you to write down your answer exactly as you would for an examiner. A spectrum shows a broad absorption between 3,230 and 3,550, and a strong absorption between 1,000 and 1,300. Identify the bonds and suggest the functional group. Okay, check out the model answer here. Notice how it requires you to explicitly state OH bond stretching for the 3,230 to 3,550 range and CO bond stretching for the 1,000 to 1,300 range to actually get the marks. Put them together and they prove the functional group is an alcohol. Like we said earlier, specificity is everything. Let's look at question 2. You already know compound X is a carboxylic acid based on those two massive peaks, but this is a classic, slightly tricky exam question. How do you confirm the exact identity of compound X using a known sample? Think about what region gives away the exact molecule, not just the family it belongs to. And this is exactly why you can never, ever ignore the fingerprint region. It is your ultimate confirmation tool. To answer this, you'd say you compare the fingerprint region, that 400 to 1,500 range, and match its complex dips to a known reference spectrum. Boom, that secures your full 2 marks. Moving on to question 3. Explain why the OH absorption in an alcohol appears as a broad peak. This specific 2-mark theory question trips up so many students who just memorize the numbers, but not the why. Let's break down the perfect full-mark response. The logical flow here is absolutely crucial. First, you state that the OH bond is involved in hydrogen bonding. Because of this, the bonds exist in a range of different environments and bond strengths. Finally, this variation causes absorption over a range of wave numbers rather than one sharp frequency, which gives us that broad peak. So the big takeaway here is to memorize that exact sequence of keywords. Broadness is caused by hydrogen bonding, which creates a range of environments, resulting in a range of wave numbers. Lock that exact chain of logic into your brain, and you'll guarantee those 2 marks every single time. Finally, Section 6, Final Exam Tips Summary. Let's wrap up this masterclass with your ultimate revision checklist to ensure nothing slips through the cracks. I'd highly recommend taking a quick screenshot of this checklist. Remember, always identify the bond and the group, never just the atom. Know the difference between a simple alcohol, OH valley, and the massive, swamping carboxylic acid, OH, that comes paired with the sharp COO. Always use the fingerprint region for exact identity and blame hydrogen bonding for OH broadness. Master these rules, practice those past papers, and ask yourself, what other invisible chemical mysteries are you going to solve now that you know exactly how to read the evidence?